This is part 4 of factoring expressions of the form of x squared plus bx plus c. Let's continue looking at some more examples. So far we've been looking at basically simple trinomials, right? Simple trinomials. But what do we have here? We have a complex trinomial, right? The a value is equal to 3, b is equal to negative 12, and c is equal to negative 36, right? So let's just remember this. Right? Now this is a complex trinomial, right? So first, and from now on, whenever we're factoring, we got to remember this. First, let's try, we're asked to factor this, right? To factor fully, right? Let's always try, when we're factoring, let's always begin by finding the greatest common factor among all three terms of this expression, right? So first, let's ask ourselves, is there a greatest common factor among all of the terms? Yes, so we can factor out the 3, right? So let's factor out the 3 first. Open brackets, this gives us x squared minus 4x, right? And minus 12, right? So we factor out the 3 out of this expression, and now we're left with this expression in the brackets, right? Now this expression in the brackets is a simple trinomial, so now we can basically use what we have, the technique that we have just learned to factor simple trinomials, right? So essentially we're looking for two numbers, right, that when you multiply them you get negative 12, and when you add them we want to get negative 4. So what are these two numbers? Well, let's start with the x's first. That will take care of the x squared, right? The product will have to be negative in this case, so that means that both numbers are going to be either both, they're going to have different signs, right? One is going to be positive, the other is going to be negative, right? If the product is going to be negative, right? So positive times negative will give us a negative. Now, what are these two numbers that when you multiply them will give us 12? Well, we know that 6 times 2 gives us 12, and we know that if we add them or we subtract them, we can get a negative 4 there, right? So that means positive 2 times negative 6 will work, right? Positive times negative, negative 2 times 6, 12, plus 2 minus 6, right? When we add positive 2 and negative 6, we get negative 4. So these are our two numbers. We've just factored this expression, right? Let's look at one more example here. Same thing. B, we have negative 2x squared plus 2x plus 4, right? Same thing. Is this a simple trinomial or a complex trinomial? Well, it's a complex trinomial. But so first, let's find out, is there a common factor among all these three terms? Yes. Some people may say 2, but we can make our life easier, right? And it's better to factor out the negatives, right? So that it's better to try to leave the coefficient of x squared with a positive 1 if possible, right? In other words, to turn it into, to get as close as we can to a simple trinomial, right? So let's factor out the negative 2 out of each of these expressions. Remember that. So negative 2, okay, so we factor out the negative 2, open bracket, negative 2 times what in order to get negative 2x squared? Well, times x squared, right? How about negative 2 times what in order to get positive 2x? Well, negative times negative will have to give us a positive, and then 2 times what to get 2x? Well, times x, right? So negative times negative, positive, 2 times x, x, right? And negative times negative to get a positive, and then 2 times 2, 4, right? So we have just factor out the negative 2 out of each of these, right? One of the main reasons why I wanted to point out this example is because, well, we're factoring out a negative term out of each of these expressions, right? So let's move this up. Alright, so now essentially we're left with this. Now we're looking for, let's continue factoring this fully. We're looking for two numbers that when we multiply them, we want to get -2, and when we add them, we want to get -1. What are these two numbers? Well, once again, let's take care of the x squared, so x times x, x squared. And these two numbers will have to be either both positive or both negative, because the product, once again, one will have to be positive, the other one will have to be negative, right? If the product will have to be negative. So, and since the sum has to be negative, let's do this. Negative times positive will give us a negative product, right? Now, what two numbers will give us 2? Well, not many options there. 1 times 2, 2, right? We want to get a sum of -1, so most likely -2 times +1 will give us -2, and when we add these two, we get -1. So that is our answer. Right? Continue looking at the rest of the examples, and we will take it up.